Skylar Hart with Team 2. This is going to be our final progress report for the Senior Design Lab. Our project was to collect and characterize RF signals using software-defined radio. Our project mentor was Todd Simon from General Dynamics Mission Systems. Our team members are Marco Martinez, Hunter Riley, and Guillermo Salcedo. We first want to delve into the budget and the timeline of the project. Then we're going to go over how we detected RF signals, and next we're going to explain the signal analysis. Finally, we're going to wrap it all up with the limitations of our system.
Hello, my name is Marco Martinez from Team 2, and I am here to talk about the budget and timeline sections of our capstone project. First of all, the capstone project required 35 hours of work every week. In terms of money, the supplies totaled to $1,428, which means that we only used 14.82% of funding. Now, I am going to discuss the timeline. The four major phases were initial planning, research, development, and implementation. While working on the project, we had to make schedule adjustments to make room for development. The most notable changes were the removal of the Prepare Progress Presentation task, shortening of the Prepared Demonstration task to 9 days, and lengthening the implementation, testing, and addition of functionality task by 24 days. The original schedule was made in anticipation of such changes for the sake of building the project.
Hello everyone, my name's Hunter. I'm going to share with you some of the things that we discussed during our demonstration. So for the signal detection portion of our project, we chose a program called GRScan. And it's a terminal run application that uses was programmed in the Genie Radio C++ API. You can call it from within MATLAB, and it'll print everything out to the MATLAB command window as pictured on this slide. It detects peaks in the log power FFT of the signal, or the fast Fourier transform. Once it detects the signal, it finds the peak power, the bandwidth, and the intermediate frequency, which is really just the current frequency that the scanner is set to. Once it finds a signal, it records a 400 millisecond sample of that signal and stores it into a binary file in the form of 8-bit in-phase and quadrature pairs, which is real and imaginary components. And then the signal information and the binary file location are saved into a CSV file, and all of that gets passed on to our MATLAB script.
How you doing? My name is Guillermo, and by now you guys already know what our project is about. We're doing collection and characterization of signals using SDRs. I know Skylar talked to you about the mentor of the project, described it a little bit. Marco talked about the budget. Hunter talked about the signal detection. Well, my main role was doing the signal analysis, and that's kind of where I concentrated at. The two main signal analysis portions that I worked on were the modulation identification, both for AM and FM. Like I mentioned previously, we already had the FM identification portion done. We added some robustness to it to make it identify whether the likelihood of a signal being FM. We also finished the SAM portion, which happened to be actually a little bit more challenging based on the fact that it uses some convolution on the bottom. And it tends to be towards the bottom spectrum in the frequency. So that was a little bit of a challenge. Also, the low sampling rate presented a lot of challenges on that sense, so we couldn't use the IQ components as such separately. We had to use some frequency analysis and some evaluate behaviors across FFTs. But that's really about it. That's as far as we got. You guys take care.
While we do have a good process in place to analyze signals, we do have some serious limitations. One of those is the sampling rate, and this is limited by the HackRF that we use, the SDR. It has an 8-bit sampling rate, and it basically limits how accurately the signal is digitized. And this in turn limits our bandwidth that we could actually use and actually see. The next limitation is going to be the type of modulation that our system can detect. There are dozens of different types of modulation, and there seems to be different flavors and combinations of each one. So we decided to focus on the two main types of modulations that we see every day, and that's AM and FM. And this is one of the reasons why we consider our project to be a success, is because we're able to create analysis that accurately characterizes both of those types of signals. Thank you and goodbye.